Okay, guys, so this is part two of lesson nine, and I just want to recap on what we said. So, first of all, let's look at these definitions. So, a polar molecule, remember, water is a polar molecule, is a molecule that has two oppositely charged poles, and that is also known as a dipole. Now, an aqueous solution is a solution in which the solvent is water. Now, a salt, an ionic salt, undergoes the process of dissociation when we dissolve it in water. This is the process in which solid ionic crystals are broken up into ions when it's dissolved into water. It splits into the ions. Hydration is the process in which ions are surrounded by water molecules, and solubility is the maximum amount of substance, the solute, so the salt, that may be dissolved in the solvent. So that would be the water. So we get a point which we call a saturation point, after which we can't dissolve any more salt in a given solution of water or a given amount of water. And that's because all of the water molecules have now have dehydrated the ions, and they aren't available for any ions anymore. Now, I just want to pause it here because I want to show you a video where we are going to look at this process of water dissociating a sodium chloride. Okay, guys, so here you will see there's our sodium chloride crystal, and there's our water molecule, that being the hydrogens and that being the oxygen atom. It's polar, it's got a positive side and a negative side. Okay, so here's our chloride ion represented by the blue balls and the red balls representing the sodium ions. So as the water molecules approach these sodium chloride ions, I want you to see that the positive side is around the negative chloride ion, and the negative oxygen atom side is around the sodium ion. And so these water molecules continue to displace these ions due to the attractive force, the electrostatic force that will occur between the water molecule and the ions. And therefore, it's now able to dissociate the salt from its crystal. And this process can only take place because it's energetically favorable for this to happen. So it's a more stable state of affairs that we will get. The next property of ionic compounds that we are going to look at is the fact that they are hard but brittle. Now, what do we mean by saying they are hard but they are brittle? Okay, so first of all, hard means that the crystal is able to resist a large force applied to it. Brittle, on the other hand, means that when the force is applied and it becomes too strong to resist, the crystal will develop a fracture that will cause a split in the whole crystal lattice rather than a small dent. Now, both of these properties are related to the patterns in which the cations and anions are arranged in the crystal lattice of ionic salts. Now, this repeating form means that we've got oppositely charged ions close to one another. Now, the moment I apply a force, what will happen? This is what's indicated in this image over here, and I want to enlarge it so that we can see what is happening there. So if I apply a force, let's just move it over to this image. If an external force is applied, what happens? I apply the force there. Now there's a shift in my crystal lattice, and I want you to see what happens here. Due to that shift in the crystal lattice, I get it that like charges come closer together. And what do like charges do with one another? They repel. And that repulsive force then is more than the attractive forces that keep the crystal lattice together all the time. And at those places where you have those repulsive forces, you will get that the crystal will crack. So even though the ionic compound is hard, it is still brittle. So the cations in one layer are now lined up with other cations in a nearby layer. And the same, the anions from one layer are lined up with anions in another layer. And these anions that are next to each other, they have like charges. And like charges, we know, repel. And therefore, these layers will split apart, and then the salt will shatter along a line extending through the crystal, which we know as a cleavage plane. Well, guys, I hope you enjoyed this lesson and that you can now attempt the questions on this section. Good luck.